Hello, my name is Adam. This is the fourth video in my series to learn how to make Super Mario Bros. In Unity. If you are looking to start from the beginning of the series, there's a link to the full playlist in the description of the video. This video in the series will focus on block items and power-ups. If you need help at any point in the tutorial, feel free to join our Discord community where we can offer direct help. There is also a link in the description of the video. Please consider subscribing to the channel to support the amount of effort it takes to create a video like this one. It would mean a lot to me and it helps drive the growth of my channel. Thank you. Enjoy the video. Alright, let's continue where we left off. Let's start by focusing on the blocks and eventually power-ups. But before we can get to power-ups, we need to create a script that allows Mario to actually hit one of these blocks, and then we'll handle animating the block when you hit it and things like that. So let's go ahead and go to our scripts folder and create a new C# script. I'm going to call this block hit. I'm going to add this script to some of our prefabs. So I'm going to add it to our brick prefab because the bricks are hittable blocks and some of the bricks will produce coins when you hit them. And then let's also add this to our mystery block because also, once again, that's a block you can actually hit and it would spawn a power-up or a mystery item. Let's drag that onto that prefab as well. And let's go ahead and open up the script and start editing it. So I'm going to delete the placeholder or boilerplate code that Unity provides like I usually do. And to start here, we first need to detect when Mario actually collides with the block. So to do that, we can add a function that Unity provides for us called onCollisionEnterTwoD. And this takes a collision2D parameter here. So onCollisionEnterTwoD allows us to detect when something has collided with our block. But we need to verify what that object is. So let's add an if statement here to say if collision.gameObject. So this is the other game object that's colliding with our block in this case. We can compare the tag to see if this is the player or Mario. And if it is, well, now we can handle some other logic. Now the problem is we need to detect which direction Mario is hitting the block. Because if you're standing on top of the block, if you're falling and landing on the block, that's not going to trigger the power up or coin or anything like that. You have to hit it from underneath. Mario has to be moving upwards. So we can use the .test function that we've been using in a number of places. This extension method we built out to do a .test. The .test checks if two vectors, how similar two vectors are. So we can detect the direction Mario is moving, compare that to just the direction up. If those two vectors are very similar, then we know Mario collided with the block while moving up. Versus if Mario's falling, those two vectors are going to be exact opposites of one another, in which case our .test function here will not pass. So let's go ahead and say if collision.transform.test. We're going to be testing this transform. So collision.transform is Mario, and this transform here is the block. If Mario hits this block while moving up, then we know they hit it in the correct direction and we can actually proceed from this point on. Let's go ahead and actually create a new function to handle the logic of actually hitting the block. So I'm going to just make a function there called hit. I'm going to call that here. And then we can start to actually move on to the logic here. So one of the things we have to implement for our block hits is there's a maximum number of times you can hit the block. There are some blocks you can only hit it once, like the power-up blocks, and there are others where you can hit it multiple times or indefinitely. So let's define a public variable here, an integer, and call this max hits. And let's give this a default value of -1. So -1 will represent that a block can be hit an infinite amount of times. Really any negative number, we're going to say that that means it can be hit over and over and over again. It will never break or never become an empty block. And so the first thing we want to do in our hit function is decrement this value. So we're going to just say max hits minus minus, which means you're just subtracting 1 from it. And so what this means, let's say the block can be hit 1 time. So for some blocks, we'll set this to 1 in the editor. This would get decremented, so then it becomes 0. At that point, if we know the, we can check if max hits equals 0. Well, now we know that this block should break or become an empty block, and we can change it. And let me set this back to -1. Now, in the case that, so actually, let's say in the case that it is -1, which is supposed to mean that you can hit it infinitely. It's -1. It gets decremented, so then it becomes -2. Well, this check won't pass anymore. It's not going to pass. -2 is not equal to 0. So because it's negative, you're just going to keep going further and further into the negatives, which means you'll never trigger this condition, which means you can just continue to hit the block over and over and over and over again, which is what we want in some cases. Now, when you do, in the cases where there is a limited number of times you can hit the block, we need to swap out what sprite is active on the block. So we should define another public variable here for a sprite. We'll call this empty block. So this will be the sprite that represents what the block looks like when it is empty or broken. You can maybe call this like, yeah, something like empty or broken or something like that. So in our hit function, we do need to get a reference to our sprite renderer so we can actually update the sprite. So we can just use our get component function to do this. It's just going to look on the same object that our block is on for this component. And here we can update our sprite to be that empty block sprite. Now, the cool thing with this is you don't have to assign a sprite. So if you left this empty, like literally left this value empty, well, then the block would just become invisible, which is kind of nice. Basically, it would make it look like the block is gone completely. Or if you wanted, you could actually assign a sprite to change its appearance. Okay, the other thing we want to do from here is animate our blocks when you actually hit them. And for this animation, we'll use a coroutine. So let's define a coroutine, which actually means we need to import using system.collections. Then we can define a coroutine down here. We have to give our function the return type enumerator. I'm going to call this animate. And then here in our hit function, we can start a coroutine and we'll call our animate function there. We also should set a Boolean to indicate whether the block is currently being animated or not. So this one can be private. So let's make a private Boolean, just say animating. And we'll set it to true initially. At the very end of the function, we'll set it to false. And then we're going to do a bunch of stuff in the middle here. The reason we have this piece of state here is because we don't want to allow the block to be hit again if it's currently animating. So what we can do is just add a quick little condition here to say if it's not animating and it is the player. So as long as the block is not currently being animated, then you can actually hit it. It'll proceed with the logic. But if it's currently being animated, then we don't want to like allow a second hit simultaneously. In terms of the animation itself, we're just going to kind of move the block up and back down. So let's get the initial kind of resting position of the block, just kind of its normal position. I'll call this resting position. And this will just be whatever its current position is. But we want to do it in local space. We're just going to move the block in our local space here. That way, if for whatever reason the block was attached to another object that was moving, it would still, the block would still move with that other object while still being able to be animated. Okay, and then let's calculate our animated position, which will just kind of be its like bounced up position. And this is going to be the resting position plus vector3.up, but it doesn't need to go a full unit up. So vector3.up would be the value 0, 1, 0. So it'd be push it 1 unit up. That's more than we need. We really only need to make it animate half a unit up. So we can multiply this by 0.5 or divided by 2, either or. So that's going to be our initial position, our animated position, and then we can actually animate this. Now we need to do sort of 2 animations, first it going up and then going back down. So we can actually define another function here, same return type IEnumerator, and we'll call this maybe move. And let's pass in 2 values, a from position and a to position. That way we can do all the logic of actually moving the block from one position to another. And we'll just use that, we'll just call that twice, right? So here we're going to say yield return move from the resting position to the animated position. And then we'll call it again, yield return move animated position to the resting position. So you go from resting to the animated, and then from animated back to resting. So that's it for this function. Now we just need the actual kind of movement animation logic here. And if we were using like a tweening system, this would be really easy, but for the sake of it, I feel like it'd be like kind of a lot to teach people about what tweening systems are. So we're not gonna do that right now. So I'll kind of show you how you can animate this without using any kind of tweening system. We need to keep track of how much time has elapsed, which will initially be 0. We need to define a duration for the animation. So let's say it takes maybe 1/8 of a second. It's just a quick little animation up and down. While the elapsed time is less than the duration, we will continue to animate this. From here, we need to calculate the percentage of time in the animation. So we'll call this T. And this is just elapsed divided by duration. Right, so if elapsed is 0 and the duration is 0.25, well, T, you're 0% through. If the elapsed is the same as the duration, you're 100% of the way through, when T would be 1 in that case. And then obviously everything in between. And then we can simply interpolate between the two positions here. So we'll say transform.localPosition equals vector3.lerp. Lerp is linear interpolation, so it's just getting the point between 2 other points given some, percentage. So this is from 2, and then T is our percentage. Then, of course, we need to update elapsed time by how much time has elapsed since the last frame. So that's time.delta time. Then we yield, so it'll wait until the next frame to continue on. And finally, once this entire loop is done, so the duration has been met, let's just make sure that our object is in the exact right position, in that exact right final position. So we're just going to set our local position equal to 2. Because sometimes the elapse won't perfectly match the duration, in which case the position won't perfectly match either. So we're just going to set that. All right, so that's really it for this. Let's go ahead and test this. And we should also assign some of those values in our prefabs here. So for those scripts we added, and if you need to add those scripts again, for our brick here, for the empty block, we have an empty sprite. So if we go to our sprites folder, there should be, there's an empty block here. So we can assign that there. And for the bricks, normally speaking, you can hit them over and over and over again. So those will keep at -1. But for our mystery block here, this you usually can only hit 1 time. So let's assign max hits to 1. And this can also use that same empty block prefab. And make sure, or not prefab, so we do have an empty block prefab, which we actually don't need, but make sure we assign the sprite, not the prefab. Empty block sprite. If it doesn't let you drag it in, that means you're assigning the wrong type of object. Okay, let's go ahead and test this out, see if it works. Yep, so you can see I hit it, it bounced up, and then it switched to the empty block. And for these ones, I can hit it over and over and over again because the max hits is set to -1. But now for the mystery block here, I hit it, it gets switched to the empty block. So this looks great. There's only one small problem with what we've currently done, in that once it switches to the empty block, you can still hit it again. It'll still animate, which we don't want. So you can see here, once this switches to empty block, I shouldn't be able to hit it again. So this is just a quick little update we need to make in our script. All we need to do is add another condition to our statement here to say if it's not currently animating and the max hits does not equal 0, and it's the player, of course. So we add that extra condition. If the max hits is not 0, then you can hit it again. Otherwise, if max hits has been set to 0, which means it's been set to the empty block, well, now you can no longer hit it. So now I hit my head, but the block doesn't animate anymore. So that's good. There's one neat thing we can do also, which deals with hidden blocks. So let's say we wanted a block to be hidden, which in some of the Mario levels there are. In fact, I think in 1.1 here, there's actually a hidden block that sits right around here. I don't know if I added this. I might have. I don't recall if I added that or not. But regardless, let's pretend we have a hidden block. So I'll just use this one as an example. If we wanted a hidden block, we could literally just disable the sprite render. We'll keep the other components because we still want to detect the collision and have the block hit. But let's disable the sprite renderer so you don't actually see it. Let's go back to our block hit script here. And all we need to do is add one more line of code and we're good to go. So when we hit the block, all we need to do is re-enable our sprite render. Now, in most cases, it'll already be enabled, but in the cases that the sprite render is disabled because it's a hidden block, we can enable it here. And this is convenient since we already have a reference to our sprite render. Just need this one simple line of code. And now let's test this out. I gotta figure out the exact location here since I can't actually see it. I know it's usually somewhere right out here. So let me kill Goomba here. There it is. So boom. So as soon as I hit it, it became visible again and it worked as it should. So that's kind of a cool thing. You can add in hidden blocks in your levels just by simply turning off the sprite renderer. And then that's it. Just turn off the sprite renderer and there's that one extra line of code to re-enable the sprite renderer. And then you're good. I'm going to revert this change back to how it normally is. Oh yeah, I have a hidden. Oh yeah. So I did add this. It's just the whole game object's turned off. So let me turn this game object on. I'm going to disable that sprite render. So this, in my case, this is where the hidden block is supposed to be on this first stage. But feel free to obviously put them wherever you want. You can add new hidden blocks, or if you're making custom levels, you can do anything you want really. All right, next up, let's focus on adding our first power up. Or I guess this one's not necessarily a power up, but we're gonna add the coin. So in some blocks, when you hit them, it'll spawn a coin, or Mario just gets a coin from doing so. And there's a little animation of the coin kind of going up and down to indicate that you collected a coin. So first, we need to actually create a prefab for the coin itself, so we can then spawn that from the block and then animate it. Let's go ahead and create an empty object in our scene. I'm going to call this block coin. And this will be different from other coins that might just be laying in the stage itself. So there are some coins that are just sitting on the stage and you can collect those. This is specific to when you hit a block that gives you a coin, it'll play an animation and so on. I'm going to reset the transform here to 0, 0, 0. Let's change the layer to power up, even though it's not really a power up, but let's set it to be power up. If you don't have that layer, go to the add layer menu item here. You can add a user layer, call it whatever. Then you'll have to go back and reassign it. For our block coin, we really just need a sprite renderer. And we can, of course, assign our coin sprite to this. So we can drag in our coin sprite there. And I'm going to set the order layer to 1. Our background elements are on order in layer 0. So we'll set this one to be 1 so it renders on top of those. But the rest of our objects, like our blocks and so on, are even higher than this. So we don't want this to render on top of those because we, in a way, want it to spawn behind the block and it animates up and back down. So our blocks, I forget exactly what layer they're on. Let's see, they're on 5. Yeah, so they're actually on the kind of the topmost. But 1 will suffice in our case. And that's really it for our prefab. Let's go ahead and drag this into our prefabs folder. And once we've done that, we can delete it from our scene. And let's go ahead and start updating our scripts now. So in our block hit script, we need the ability to actually spawn an item when you hit the block. And this will be used in this case for the coin as well as future power-ups too. So let's add another public reference here to a game object, not a game manager, a game object. I'm just going to call this item. So this will be a reference to a game object that you're going to copy or clone when you hit the block. This is the item we're going to spawn a copy of when you hit it. And here in our hit function, let's first check to see if that item is not null, if item does not equal null, because there could be some cases where you don't assign an object to be spawned, so we don't want to cause an error. If we try to instantiate something that's null, it'll give us an error. So we check that it's not null, then we can call Unity's instantiate function. We'll pass that item. The position will just be the position of the block, so that's this. That's just transform that position. And then we, for the third argument here, rotation, we don't need rotation, so we could just say quaternion.identity. And that's really it for this. We don't need to do anything else. This just simply spawns an item at the position of the block when you hit the block. It's then up to that item itself to handle whatever logic it needs to do. And so that's where we actually need to add a new script specific to our coin animation. So let's create a C# script called block coin. And let's go ahead and add this script to our prefab. So let's open up our prefab and let's drag this into the empty space here. And now we can go back and edit this script. So this script is really just handling the animation code for that coin. There's no real logic to this. You collect the coin automatically the second it spawns. So in fact, normally speaking, I delete the boilerplate. I will keep the start function here because we are going to use the start function. The start function gets called automatically by Unity the very first frame that this script is running, is enabled and running on its object. So here, when we start, we need to actually update, we need to collect the coin. And what that means is we need to update our game manager, the state in our game manager to say Mario has, another coin now. And we don't have any variables yet to define how many coins Mario has. Let's go ahead and define that. We'll add a public int for coins. And I'll make this public getter with a private setter. And let's go ahead and add a function at the bottom here called a public function. It needs to be public if we're going to be able to call it from our new script there. Let's call this add coin. And we will simply say coins plus plus. So that's just incrementing it by 1. Now I do believe in Mario, if you collect 100 coins, you get an extra life. So we can say if coins equals 100, then we can add a life to the player. Let's actually add a new function for this. This will also be a public function called add life. The reason we're adding this function is because we will reuse this same function later when we have a 1-up mushroom power up. So there's a 1-up mushroom that would just simply gives you a life. So we'll use this function for that as well. But in here we can say lives plus plus. And that's all we're going to do for now, but in theory, you would, most likely do more than just that. You would probably update your UI and things like that. So we're not going to handle all the UI right now. But in theory, your game manager would reference your UI components and you would update your UI anytime these values change. So if coins equals 100, we add a life, and then we should reset coins back to 0 so you can go and get another life once you collect another 100 coins. And then finally, in our game manager here, we should probably reset our coins to 0 whenever you start a new game. And I think that's good for now. So back to our block coin. So when this first starts, we can say game manager.instance.add coin. So you immediately collect the coin upon the script starting. But then from here, we actually want to do the animation just to give that feedback to the user that they have indeed collected a coin. The animation for this will actually be very, very similar to our block hit, where it just kind of goes up and back down. So why don't we actually just copy this code for now? And obviously there are better ways than just simply copy and pasting this code, but for the sake of time is totally fine. We'll copy those two functions, our animate function and our move function. I'm getting some error here because we need to import using system.collection. System.collections, sorry, plural. And this animating variable we haven't defined, but we don't actually need that for this one, so we can just delete that. In terms of the code here, I'm going to make the duration a little bit longer, so I'm going to make this 1/4 of a second instead. Obviously, feel free to play around with that. And our animated position will also be different. Instead of it just going up half a unit, I actually want it to go up 2 full units. So it kind of really goes up and back down. So we'll just multiply by 2 instead of half. And that's really it in terms of the animation itself. We do need to start the animation. So in our start function, we'll say start coroutine, animate, just like we did in our block hit script. And let's see. Oh, and then finally, the last thing is once the animation finishes, we can just destroy this coin object. It doesn't need to exist anymore. So we can simply say destroy game object. Game object here is referring to this game object, the coin. And I think we're good. Let's test this. We did add this already to our, let's double check. Let's make sure we added this. Yeah, so on our prefab, we added our script. There's no variables or anything we need to assign, so that's all good. Then we do simply now need to assign this prefab as the item that spawns when you hit certain blocks. So really, you can feel free to go through your scene and assign this. As an example here, I'll take this first block, which I believe is in fact supposed to be a coin. Or maybe I'll do this. Maybe I'll select all of my mystery blocks here, and I'll assign our block coin to them. So I'm dragging in my prefab to the item slot. And then later when we add some of our other power-ups for mushrooms, I'll override this and set it to something different. But by default, by default per se, we'll set our block coin to be kind of what happens when you hit a mystery block. So let's test this. Let's get Goomba out of the way here. So when I hit this, we should see the coin animate, a couple units up and then back down. Yep, there we go. So that looks good. I think there's maybe one other thing I want to do, which is I feel like the coin is a little bit too big. So I'm just going to change the scale of this here. Uniformly, I'm going to change the scale maybe to like 0.75. There are some coins that are just sitting in the world itself that you can collect, in which case the scale of 1 I think makes sense. But for this is just a simple animation. I feel like it looks better to just be a little bit of a smaller representation. So that looks great. That all is good. And I think we could even check our game manager here. Yeah, so coins, we now have 1 coin. So I just switch to the debug mode and I can see some of those hidden properties. So great, that is it for our block coin. All right, now let's focus on creating our different power-ups like the mushrooms and so on. And there's gonna be a bunch of different steps we gotta take here. Maybe let's start by just creating our prefabs for our different power-ups like the mushrooms. I think really just those 2 mushrooms for now. So let's go ahead and create an empty object in our scene here. Maybe I'll start with the 1-up mushroom. So I'm going to call that 1-up mushroom. I'm going to change the layer to power up. I'm going to reset the transform here. There's a bunch of different components we need to add. So let's add a sprite renderer. We can assign our sprite here, 1-up mushroom. The order layer will be 1. So all of our power-ups will be on 1, just like we did for our coin. We set that to 1. Let's add a rigid body because these objects will actually move around in the world once they spawn from the block. So rigid body 2D. We can assign our no friction physics material, which just helps smooth out some of the friction with any potential little collision bugs that might have happened on the ground there. We don't need drag. We can freeze the rotation. We can set the interpolate mode to interpolate. This helps smooth out the kind of rendering and the physics, because the physics engine runs on its own cycle compared to the rest of the game, the rendering and so on. So sometimes you can get little jitters between the object moving and actually getting rendered. So this helps smooth that out. Not necessarily needed, but it does help sometimes. We also need a circle collider 2D. This will be for the actual kind of movements of the object here. So let me kind of show this. So this will be for the actual movement of our mushroom as it goes along the ground. So we can assign our friction material to that as well. I am going to make the size of this a little bit smaller. You don't necessarily have to do this, but I'm going to make this maybe 0.375. And then I need to shift it down so it's lined up at the bottom here. So this will be negative 0.125. That looks a little bit better. And then we also want to add a second collider. We'll add a box collider 2D. This will represent the area. This will be a trigger zone for when you collect it. So just like we did for Koopa, if you remember when we did Koopa, if you followed the other tutorials, we have two colliders. We have a circle collider and we also have our box collider. Same thing. The box collider is just a trigger. It's marked as a trigger. That'll be used to detect when you collect the item in code, versus the circle colliders specifically just for physics. So for this, yeah, I think we could probably just leave it. Just make sure we mark it as a trigger. The size and everything is good already. And I think that's it in terms of our 1-up mushroom. Maybe before I turn this into a prefab, I'm going to duplicate this. And I'm going to call this other one our magic mushroom. Magic mushroom. I can't type. Mushroom. And let's assign our other sprite here. Where is it at? Magic mushroom. There we go. Let's move this one to the side. Yeah. So we got both of those. Really, they're the exact same setup. They're just, different sprites, really. And then we also have our Starman power-ups. Let's duplicate this again. And let's drag in our Starman for this one. Starman. And I think this one could probably, just use the exact same setup as well. And then what else? We do just have a normal coin too. But the normal coin doesn't move. But might as well create it. So let's create a fourth one here. I'm just going to call this coin. This one doesn't move, so we don't need a rigid body. And that means we don't need the circle collider. We'll just keep the box collider, which is the trigger zone. And we'll update the sprite, of course, to be our coin sprite. Coin. And let's see, is there anything else? I think that's good for now. So we got our 4 power-ups per se. I guess the coin's not really a power-up, but we're kind of treating it like a power-up in a way. There's maybe one other thing we want to do. We actually do want to adjust the scale of all these to be slightly smaller than 1. Because when they spawn inside a block, they might just barely clip out the ends. So we want to kind of make sure it's hidden behind it when it first spawns. So I'm going to take all 4 of these and I'm going to adjust the scale uniformly to 0.925. It's just a little bit smaller. I guess the coin doesn't really need to do that, but we'll just keep it for consistency. Actually for the coin, we'll keep that at 1. We'll keep the coin at 1 because that one we need to manually place on the ground, and this will just help us maintain correct alignment with the ground and stuff. But for the other 3, since those will actually be spawning out of blocks, we need to make them a little bit smaller so they're properly hidden behind the block. And I think we're good there, so let's drag each of these into our prefabs folder one by one here. 1-up mushroom, magic mushroom, Starman, and our coin. Once we've done that, we can delete them from our scene. Probably should have reset their positions, but that's okay. I'll just reset their positions here in the prefabs. 0, 0 for all of these. Magic mushroom and our coin. Great. All right, so we have some prefabs now we can play around with as we move on to the next step. Okay, so now that we have our prefabs, let's go ahead and create a script that's going to handle the item as it spawns. So we need a custom script to first animate it as it spawns up. So it's going to spawn in the block. It's going to do a kind of a simple, short, or slow animation actually of it moving up right exactly 1 unit above the block, and then from there we'll enable all of its components to let it move around and do its thing. So let's go ahead and go to our scripts folder. Let's create a C# script called block item, and let's start editing this. I'm going to delete the boilerplate here. I'll keep the start function because we're actually going to use this. So just like we've done for some of our other object Arco coin, we need to start an animation when this first spawns. So let's import using system.collection so we can define a coroutine function. We'll add our enumerator, animate. We'll start that coroutine here, just like we did for our block coin, same thing. The animation itself will be definitely a lot different though. So in here, we need to actually animate it, add it from the starting position, exactly 1 unit up. But there's also a number of other things we need to do because unlike the block coin didn't have any rigid body or colliders or anything on it. It's just kind of a static object. These are actual real objects that will start to move around. So if we spawn an object and it has a collider, well, now these two things are going to be colliding with one another and going to push, it's going to push them out of each other and it's not going to look right. So we actually need to disable all of those different components we added, like the rigid body and the colliders, before we animate it. We'll animate it manually, and then once it's finished its animation and it's sitting at the right spot, we'll re-enable all the colliders and everything. So let's get a reference to all of those different components. So for example, we'll get a reference to our rigid body using the get component function, rigid body 2D here. Same thing for the others. We'll get a reference to that circle collider, which is really our physics collider. So maybe we'll call that physics collider, circle collider 2D. And we'll do our box collider. So this is our trigger collider. We'll use this to detect when Mario actually collects the item when running into it. We'll do our sprite renderer as well. And I'll explain why we need the sprite renderer too. Okay, so we got 4 different components there. Good. Let's disable them. So for our rigid body, you can't actually disable a rigid body, but you can set it to be kinematic, which means the physics engine won't simulate physics on it. But for other colliders, we can disable these. Trigger collider enabled false, sprite renderer enabled false as well. We're turning the sprite renderer off just briefly because when the item spawns right as you hit the block. But at that moment, the block is still animating up and down, which means you would see the items sitting there, which won't look good. So we're going to turn off the sprite renderer temporarily. We'll yield for just, a quarter of a second. And then we'll immediately turn the sprite renderer back on again. So this yield will give us enough time, will give the block enough time to finish its animation. That way you don't kind of see it as the block is moving up and down. And then from here, we'll re-enable the sprite and start the actual animation for the item itself. So let's define our animation variables. Elapsed 0, duration, let's say is half a second. While elapsed is less than the duration, we'll continue the animation. We'll calculate the percentage of the animation, which is elapsed divided by the duration. And then we'll interpolate the position. So vector3.lerp. We need to calculate what the positions are here. So let's get our start position. Will be whatever the current position is. The end position will be the current position plus vector3.up. And we should probably use local position, really. So we'll switch these to local position. We're moving it exactly up 1 unit. That way it sits perfectly on top of the block. So we'll alert between start position and end position using T as our percentage. And I'm going through this pretty quickly because we've done basically this exact same code in a couple different places now. So feel free to refer back to what we've done elsewhere. We update our elapsed time by how much time has elapsed since the last frame. And then we yield, make sure we yield between every cycle loop here. Finally, once the whole animation is finished, now we can re-enable these things so it'll start moving like normal. So it's no longer kinematic. It'll actually get simulated by the physics engine. We can re-enable the colliders so it has proper physics, as well as the ability to be collected through the trigger here. And I think we're good with that. Let's test this out. I do believe we need to still add this script to our prefabs. Let's go back to some of our prefabs and let's add in our block item script there. And I think we also should add our entity movement to these as well. Yeah. So for our 1-up mushroom, we should add our entity movement. So this was a script we created way back when we first implemented our enemies. They're going to move just like any other entity. The speed probably should be faster though, so maybe we'll set the speed to 3. I think the enemies move at 2, so these will be at 3. And then usually they spawn going to the right, so this should be a +1 in the x-axis. Same thing for our other one, so let's do magic mushroom. We'll add our entity movements, set the speed to 3, set the direction to be right, and then add our block item script. And then Starman as well. And the Starman, yeah, so same thing. Starman, entity movement, 3, moving to the right, block item. And we're good there. So let's test this. I believe one of these 2 blocks, which one is it? One of these 2 blocks spawns with a magic mushroom. Yeah, it's this first one here. So this first one, we can drag in our magic mushroom prefab. So we had a coin, but this really should be magic mushroom. So that's the item that spawns now. It's going to spawn this whole thing, which will play all of these different scripts to handle, you know, that spawning animation, disabling the components, and so on. Let's just test it out and see what happens. If there's any issues, we will fix it. All right, so this one right here. That was perfect. Yeah, that looked great. So now we haven't done the rest of the collision of actually collecting the object yet, so we'll get to that. But that, I mean, that looked great. It kind of slowly animated up, went to its position, and then from there it starts to it re-enables all the things, so it allows movement and so on. Maybe one minor thing is, after the animation is finished, the position might not be exactly correct. Oh, and also I just realized I changed this to be local position, but I didn't switch this to be local position. So let's make sure that's consistent. If we're using local position, use it everywhere. Otherwise, if you're not using local position, make sure it's the same. But once the animation finishes, it's usually a good idea to update the position to be whatever that end position is supposed to be, because the elapsed might not perfectly match the duration, which means the position won't perfectly match what the end position is supposed to be. So this can just help make sure it's in the exact right spot. But yeah, this looks good. I'll test it one more time for the sake of it. All right, so we've still got our coin working, and you hit it. Yeah, that looks great. There's a little bounce, but that's okay. You could potentially adjust some of the timing of the animations and so on. Maybe you make it go up just a little bit further than 1 unit, but I'm honestly pretty happy with this, so I'm just gonna leave it as it is, and we can move on. All right, from here, let's handle the unique logic per each of those individual power-ups. So we'll handle them one at a time, and we'll add in the logic. Let's start with the easy ones. So we'll do 1-up mushroom and the coin. Those are pretty simple. And then we'll do the more complicated ones like magic mushroom and so on. We do need to create a script to represent a power-up and what happens when you collect the power-up. So let's create a new script. I'm going to call this power-up. And let's delete the boilerplate here. The first thing I need to do is define an enum that indicates what type of power-up it is. So public enum, I'll just call this type. And we have a few options. We have a coin, we've got an extra life, we've got a magic mushroom, and we've got a star power. So those are different types of power-ups, at least for this tutorial, that you could collect. For our power-up here, we need to now define a variable of that same type here. That way in the editor, we can assign, so we're going to add this power-up script to each of those prefabs we had created, and we'll assign for each one, is it a coin, is it a magic mushroom? This will help us determine what happens when you actually collect the power-up. So in terms of collecting the power-up, let's add our onTriggerEnter 2D with a collider 2D other. If you recall from our prefabs, we added 2 colliders to each of them. One is the circle collider, which is just used for the normal physics of the object, and we added a box collider, which is marked as trigger. So double check, make sure yours are marked as triggers or this won't work. But this little box collider is just a little box surrounding the object to know when we've kind of entered within its zone per se, or its radius, and that'll trigger you collecting the item. And the reason we could just detect normal collision on the object itself using onCollisionEnter instead of onTriggerEnter, but the problem is there could be a brief second where you kind of bounce off of the object, and it just makes the physics not feel as smooth. It doesn't look as good. So that's why we have the second collider to just just kind of separate, just create a little bit of separation between the two. Just makes it feel and look better, in my opinion. You don't necessarily need to do that, but anyways. So onTriggerEnter 2D, let's check which object we collide with. So if other.compareTag to player, then we can go ahead and collect the item. So let's define a function called collect. I actually do want to pass a reference to the player because we will need that for some of the power-ups. Like for the magic mushroom and star power, those are affecting the player. So we're going to pass a reference to the player. But we'll call this here collect, and we'll pass other.gameObject is Mario in that case. All right. When we collect, we need to switch on what type it is so we can handle the respective logic. So we'll add a switch statement here. We'll switch on what type it is, and we'll add a case for each one. So if it's a coin, we'll do something, and then after each we need a break. So we'll copy this a few times. So we got our 4 different ones. Let's update these. We have coin, we have extra life, we have magic mushroom, and we have star power. So like I said, we'll handle each of these one at a time now. And once you've collected the object, now we can destroy it. So we just destroy game object at the very bottom there. All right, so that's it in terms of our power-up script. Like I said, we'll handle the logic. Let's go ahead and add this to each of our prefabs. Once it reloads, compiling all the scripts here. It's taking way too long. There it goes. Okay, so for our 1-up mushroom, let's go ahead and add our power-up script, and let's change the type here to extra life. And then for our coin, same thing. Let's add our power-up. It's already set to coin as the first value, so that's good. Magic mushroom, add our power-up, and switch this to magic mushroom. And then for Starman, we will add the power up and switch it to star power. All right, so that gives us the ability to actually collect these power ups as you walk into them, and then trigger some logic based on the type there. So for the types themselves, let's get the easy ones out of the way. Coin and extra life. One line of code, real simple. We already actually have it. We just need to go to our game manager and call add coin or add life. So for each of these, game manager.add or game manager.instance add coin. That's it. And then same thing for this one, game manager instance add life. And so those two are done right away. Nice and simple. Let's test these out. You should actually go through and assign the prefabs to the right blocks. I suppose we could do that. Let me check real quick where the different blocks are. So let's see. So 4 of our mystery blocks here. The first one's a coin. The second one is our magic mushroom. We assigned that earlier. Then we've got coin. Then the next one down here should be a magic mushroom. Obviously, feel free to customize this. It doesn't have to be this, but based on this original level, this is a magic mushroom. This one here is a coin, so that should already be set. These three over here, we've got coin, and then the magic mushrooms at the very top here. So let's assign our magic mushroom to that top one. These two, I think, are just coins. Yeah, those two are coins. And then this one over here should be a coin as well. And then we have our 1-up. We've got our 1-up in the hidden block. If you did add the hidden block, where's that at? It's way over here somewhere. Yeah, this is actually a 1-up. So you can get an extra 1-up on the very first level of Mario from this hidden block. So there's, I think, 2 magic mushrooms. Or 3 magic mushrooms, I guess. Is that right? I thought there's supposed to be a star power in one of these. In either case, here, let me check one more thing. I have this reference image in the repo. Yeah, there's, oh, okay, so the star power is actually hidden in one of these bricks. So this is a reference image in the GitHub repo. I think there's a folder just called references. It shows kind of what's what. So this is magic mushroom. You've got this hidden one, which is the 1-up, another magic mushroom, another magic mushroom. There's actually kind of a hidden, it's not hidden and like the block is there, but you don't normally think to look at some of these bricks as having like power-ups or anything. So, and actually there's a coin in that one too. So let's go and add those real quick. So that was, this here actually has a coin in it. So we can assign our coin to that one, which means this should have a max hit of 1. But then once you, actually, how does that work? Oh, I recall. So this block, it has a coin. You can actually hit it 5 times. You're able to hit this brick 5 times and you'll get 5 coins. You'll get a coin each time you hit it. And then it becomes an empty block. And then this one here has the kind of hidden Starman in it. And I believe that one, you know, definitely can't get 5 of those. That one you can only get once. So set the max hits to 1 and then it becomes an empty block. Let's quickly test this out. Let's see that each of these spawn at the right positions. So we've got our magic mushroom there. Yeah, so I collected it. We haven't added the logic for that one yet, but I was able to collect it. We've got our hidden block right there. We collected the 1-up. And actually that one we can test because we did add the logic. Let me pause the game and go to our game manager. Switch to debug mode. Yeah, so I have 4 lives now when I started with 3, so that worked. And this is another magic mushroom, which we haven't implemented the logic for yet. This is a coin, 5 coins actually. Oh, is that working? That doesn't appear to be working. Coin. Oh, so I assigned the wrong prefab. This coin is the coin that's supposed to be sitting in the world. I was supposed to assign a block coin to this because the block coin has the animation. There it goes. So as you hit that, it does the animation. I think I still was rewarded the coins for that, but it just didn't have the animation because I assigned the wrong prefab. Yeah, so I still got all the coins from it, which is good. But, and then finally, this one is our Starman. Perfect. So all that's good. Everything's there. Now, because I changed this one while the game was running, it doesn't save that change. So let me go back and switch this to be a black coin, and we're all good. So all of our power-ups are in the right locations. We tested the logic for coins and for the extra life. All that's good. Now we can move on to the other two power-ups. All right, let's go ahead and implement the magic mushroom power-up, the actual logic for it. So in our power-up script here, we have the to-do here for magic mushroom. So what do we actually need to do here? Well, when you pick up a magic mushroom, Mario grows into his bigger version. And we have already started to put we already previously kind of set up some of the structure for this. So we already have like the big and small sprite renderers all set up on Mario's prefab. We even have a shrink function. We should add a grow function as well. And this should be public because we're going to call it from here. So we'll call this grow. So we have grow and shrink, and I'm going to actually move both of these down below the depth function. So grow is what we need to call from here. This function exists on our script simply called player. So we need to get a reference to that component. This parameter here is called player, but that's not the player script. That's just a game object. So we need to say player get component. We're going to get that player script or component, and then we'll call our grow function on it. So in our grow function itself, we need to do a couple things. We need to swap out. We need to kind of enable the big render and disable the small renderer. So when we do that, we'll say small renderer enabled is false, big renderer enabled is true. And then we should keep track of which is the active renderer. And that's because we're going to do the animation of you growing. It kind of cycles between the small and big. Like every few frames, it'll go small and big, small, big, small, big, just to look like you're kind of growing. But we need to know like what's the final renderer that's supposed to be enabled once the animation is finished. So we'll keep track of a private reference to the player sprite renderer. We'll call this the active renderer. So that will be a reference to either the small or the big one. And this is private. Active render. So when we grow here, our active renderer is the big renderer. Now we also need to adjust Mario's not prefab. We need to adjust Mario's collider. So let me show you. Let me pull up the prefab. If we go to Mario, we have this capsule collider, which defines his collision area. Well, once he's the big version, well now he, the capsule collider needs to be bigger to match his updated size. And also Mario, the big version of Mario here is not positioned correctly either. So we have the small version, we have the big version. This needs to be lined up like this. So, because otherwise Mario's gonna be clipping through the ground. So just for the big version, not on the parent, but on the big version, we need to bump this up half a unit. Good. So now when that becomes enabled, you can kind of see it's lined up correctly. We'll keep it disabled initially. All of these things should be disabled initially on the big renderer. But yeah, for the capsule collider, when Mario is big, so let me actually turn that on for a second. When Mario is big, you can see the collider doesn't match him at all. We need to adjust it so it does match. So we will change the size. We'll change the size on our... Sorry, I didn't mean to open that. We'll change the size on the capsule collider and I think the offset as well to match. So Mario, when he's small, is just a 1, like he just takes up 1 unit. So size is 1, but when he grows, he's now 2 units. So we'll change it to 2, but you can see the, it doesn't align with him correctly. So that's where we'll have to then also adjust the offset by half a unit. but where we need to do this in code, not here in the editor. So let's reset all this. Keep it at the small version. So 0, 0 is the offset. Size is just 1. Let's return on the small, turn off the big. Oh, it's just to demonstrate what we need to do via code. So in our player script, we need to make those same changes we just did in the editor. We need a reference to the capsule collider. We don't have one of those yet. So let me add a new capsule collider 2D reference here. I'll call this capsule collider. We can assign that in our awake function. Get component capsule collider. Oh, and this should be 2D. Yeah, 2D. Make sure it's 2D. Here in the grow function, we just need to do those same changes we made. So we can say capsule collider dot size equals vector 2, 1 in the x, 2 in the y. So it takes up 2 units now. And then the offset here will be 0 in the x, but half a unit in the y to align it correctly. And we're good there. Now for shrink, it's really the exact opposite. So let's take all the same code, but now we will enable the small renderer. We disable the big renderer. We set the active renderer to be the small renderer, and the size goes back to 1 and the offset goes back to 0. Great. So that's just changing the state of Mario, but that state happens instantly. We should still place some kind of animation to make it feel good, to make it look and feel good. So let's define a function here for animation coroutine, which means since we're making a coroutine, you might already know at this point, since we've done this several times. Import system.collections. We'll create our coroutine here. I'm going to call this like the scale animation, because we're going to use the same animation both on grow and shrink. So yeah, both in grow and shrink, we'll start this. We'll call the scale animation in both cases. And what we're going to do in here is kind of toggle which of these two is enabled. So we're going to kind of go back and forth between which is enabled, which will create a nice effect, which will maybe make more sense once we can actually see it. Let's define our animation parameters here for elapsed, and duration will be maybe half a second. While the elapsed is less than the duration, we'll continue animating. The first thing I'm going to do is actually increase our time here. And then we're going to do something clever here where we're going to alternate between which renderer is active every couple frames. Maybe every 4 frames, we will alternate between which one is active. So what we can do is we can get what the current frame is. So time.frameCount. We can use a modulo operator. And like I said, I want to maybe do alternate every 4 frames. So mod 4. If that equals 0, the mod is like dividing, but it gives you just the remainder. So basically, if you say 4 divided by 4, there's no remainder, equals 0. If you do 8 divided by 4, there's also no remainder because 8 and 4 divide together nicely. But let's say it was 6 divided by 4. Well, that doesn't divide evenly. So you would have a remainder, so it would not be 0. So every 4 frames, basically, that's what this is saying. Every 4 frames, we're going to switch. If the small renderer was enabled, then we're going to disable it. So we'll just not it to do, it'll just set it to be the opposite of what it was. And then same thing for this. So this just alternates between them. Oh, and then this should actually be, yeah. Both. So small is the opposite. So if small was enabled, then it becomes not enabled. And big will be enabled whenever small is not enabled. So both of these cases should be small enabled, small render on the right hand side here. All right, we will yield at that point. And then finally, once the whole animation is done, however long you want that to go for, we will now disable both of them. And then only enable which one we marked as is supposed to be the active one. So we disable both because we don't know which one it's supposed to be, because we're using this animation for both grow and shrink. So we don't know, well, should it be the small that gets enabled? Should it be the big that gets enabled? That's why we have this active renderer to keep track of which one it's supposed to be. So it's either going to be big or small. So we just disable both, but then it immediately will re-enable the correct one, the one that's marked as what's supposed to be active. So no, this is a little complicated. It's really just creating a custom animation to get a cool effect. It's not needed per se, but that animation really does help sell the idea that you're growing in size. So let's take a look, see what this looks like. Get our magic mushroom here. There we go. So you see how it kind of flickers in a sense, like it flickers between small and big, and you can adjust like the timing of that. So maybe you do every 2 frames, every 6 frames, every 8 frames. You can adjust kind of what that looks like, but this was the way that I found, this was kind of the way that I found matches the original game somewhat closely. It's maybe not perfect, but I think it does a pretty good job. And yeah, obviously now I'm the big version of Mario. So notice here, I just shrunk because I touched Goomba. It played that same animation, and then now I'm the small version again. And it all updates correctly. All the colliders and everything matches. And this is where we had already defined the logic previously when we implemented enemies to shrink the player if you're big, or if you're not big, well then you die at that point. So double check that you have this logic, because we did implement that way back when we did enemies. But yeah, if you're big, you shrink. Otherwise, you die when you get hit. And hit gets called from the different enemy scripts like Goomba and Koopa and so on. If there's the whole tutorial on just enemies. So if you skipped over that for whatever reason, you can go back and understand that. But in terms of the visual animation, this is all it is. Grow, shrink. We kind of swap out which renderers are enabled. We adjust the collider to match the size, and we play a little kind of neat animation to sell the effect a little bit better. So that is it for that. All right, we have got one final power up to implement, which is our Starpower. So let's go ahead and go to our power up script, and we've got this final to do here. So for Starpower, we're going to do something somewhat similar to what we just did for the magic mushroom, but not quite. But let's go ahead and add a new function in here maybe I'll just call it Starpower. This will be public because we need to call it from here. So why don't we do that? So same thing as we did here. We'll instead call Starpower. And then for the actual Starpower logic, it's really just an animation. Well, it's setting a state change, so we know when Mario is in Starpower. So maybe let's start there. We'll add a public Boolean Starpower here. Oops, make sure it's lowercase. I'm going to make this a public getter with a private setter. So we'll enable this or set this to true or false respectively to know when Mario is in his Starpower mode. And then from there, we will use that when we get hit to know, well, if Mario is in Starpower mode, he doesn't actually get hit. He actually will hit the other enemies. So if for whatever reason this function were to get called and we're in Starpower, then we don't want to do anything. So really the precondition here is that we're not in Starpower. Then we can do all this other logic. And while we're at it, we should probably add some logic here to say we're not in Starpower and we're not dead. So if we're already dead and somehow this got called again, we don't want to like trigger a second death. That would maybe screw things up. So if we're not dead and we're not in Starpower, then we can actually do the logic of Mario getting hit or dying based on his big or small, whatever state he's in. But otherwise, we're good there. And I just noticed something too. This is a bit of a tangent, but from the previous section, we handled Magic Mushroom. We have this active renderer here, which determines whether Mario's in his big or small state. We should set this active renderer initially to be the small renderer. in our awake function. So sorry, that was a bit of a tangent. Should have did that in the last section, but nonetheless, add that. Might not actually even be needed, but I believe that there's some weird edge cases where that could cause a problem. So anyways, let's go back to Starpower. So when Starpower is activated, let's set that state to be true. Then we will play an animation. Yeah, so let's define a coroutine for our animation. So enumerator Starpower animation here. And maybe actually I'll move this line of code in there and we'll just call this here. So we're starting our coroutine for our animation. Initially we set our Starpower to true. At the very end we'll set it to be false, and then we'll do a bunch of stuff in the middle here. The actual animation itself. Let's say float elapsed is 0, duration. You can define this however you want. Maybe it would actually be pretty neat to pass this in as a parameter. So maybe we have a duration parameter here. Maybe it defaults to 10 seconds. And then we would also need to pass it in here as well. So instead of hard coding it here, I'll give the flexibility of being able to change how long the Starpower is. So when we call this from our Powerup script, you could provide different values. Maybe it's 10 seconds, maybe it's 20 seconds, which also means you could add like a public variable here to set what that is. I won't go that far necessarily, but just to kind of show you how you could do that. Like if you wanted to have multiple Starpowers that each lasted different durations, you could define a new variable, public variable. You could tweak that in the editor per instance of your Starpower. That would then get passed, maybe it was called something like Starpower duration. You'd pass it here, but otherwise this defaults to 10, so you don't have to pass anything. It would still work fine. But elapsed starts 0. We've got our duration passed in. While the elapsed is less than the duration, we will increase our elapsed time. And then we're going to kind of do something similar here where we do like the frame count every 4 frames, we'll adjust it. Let's do the same thing. Frame count mod 4 equals 0. We're going to change Mario's sprite renderer color to be a different color. Now this won't match up to the original game exactly. In the original game, there's like a set sequence of color, like the whole sprite changes. There's like specific sprite sequence it goes through to change the colors, but it's kind of a lot of work to do that because now you have to define, there's like 4 different colors it cycles between. So you have to have 4 different sets of sprites for every one of these states. So it just gets kind of obnoxious. I'll show you a different way we can achieve a very, very similar effect. If we take a look at Mario on the sprite renderer, let's go to either his small or big. There's this color property here. This is kind of like a tint color, so it's going to multiply this color based on the original sprite. So it doesn't always look super good depending on what the color is. But this honestly suffices pretty well for creating that kind of color flickery kind of effect. We'll just basically randomize what this color is in code, and that'll kind of create a similar effect. Not exactly the same as the original, but for the sake of time and just how many different sprites we would have to set up and create, this honestly, in my opinion, works very well. For the, we know which one is active, so we have that active render. So whether this needs to work whether Mario's in a small or big version. So we need to update the active renderer, the color of the active renderer. Now, active render is actually our custom script here, player sprite render, which handles like changing the sprite based on your movement state and so on. We actually need to access the original sprite render so we can change the color. But this is private, so we can't access it. So what we should do is make this a public variable, but we can make this a public getter with a private setter. So the assignment of this variable will still be handled in this script through this line of code, but we can at least access this now in our other code. So back in our Starpower animation, we can say active renderer. Now we can say .sprite renderer .color, and we're just going to get a random color here. So every 4 frames, we'll pick a random color, and that's going to kind of create that effect of it changing. Unity actually has a function we can use to make random color. So we can say random.color HSV, and there's a bunch of parameters here. We need to provide hue min, hue max, saturation min, saturation max, as well as value min and value max. So this is using an HSV color model, which is hue, saturation, value, and then there's a min and max for each of those. So and all of these are in the range 0 to 1. So for our hue, the hue is really all we want to change. We'll keep the saturation value the same. We're just going to cycle the hue. So we'll say hue is between 0 and 1. So really that can be any hue in the spectrum. Saturation min will be 1. Saturation max will be 1. So we're forcing the saturation to always be 1. And then same thing for value. We're forcing the value property to always be 1 as well. So all we're randomizing is the hue. And we're randomizing it between 0 and 1, which is the full range of hues. So finally, once we do that, we need to yield after each loop here. And then once all is said and done, once the whole thing is finished, Starpower gets set to false, and we need to reset our sprite render back to the color white, which is just kind of the default. Let's go ahead and test this out. We also still need to implement the logic of you being able to like kill the enemies when you run into them, but let's at least test out that this is working. The Starpower spawns pretty far into the level, so just for the sake of time, I'm going to move this. I'm just going to move it here just for now, so I can quickly test this. Just assign our Starman prefab to that block there. And so we've got Starman there. So there we go. So you can kind of see how it cycles between the colors. And if you feel like that's too fast, it is somewhat based on your frame rate. So I'm getting like an insane frame rate right now. So something you could do is probably makes sense to do this in your game manager. Is we can set our application target frame rate to maybe, let's say, 60 frames a second. Because this game really doesn't, it's such an old game, it's just a 2D game with simple sprites, like there's not much performance concern. So I was getting almost 900 frames a second, which is crazy. Now I'm getting close to 60 because that's the target. So this, I think, will actually make these animated. Yeah, that just looks a lot better. It just looks a lot better. And that same thing for when you get a magic mushroom as well. When it does this animation, yeah, that looks a lot better too. So I probably should have did that earlier, but I didn't think about it. But that looks good in terms of our animation. Once again, it's not quite the original game, but it would take so much time just to set up all of our sprites based on how the original game does it that, in my opinion, it's not worth it. At least not worth it for this tutorial. Feel free to try to work through that problem yourself, though, if you want to match the original game exactly. But we still are not finished. We need to handle the logic of when you run into enemies, the enemies need to die rather than the player. So there's nothing necessarily preventing the enemies from... Nothing changes right now with what happens when you walk into the enemies. So let's start with Goomba. And when we detect collision with Goomba and the player, before we do any of this logic, we need to check if the player is in Starpower mode. We're going to handle this differently. So if he's in Starpower, we'll do one thing. Then otherwise we'll continue on with the rest of the logic as it was. Else if, else, so on. This is why we made this public getter with a private setter, so we can still access it here. And in the case of the players in Starpower, well, Goomba gets hit instead of the player getting hit. So we'll just call Goomba's hit function. And then exact same thing in the Koopa script. So if player is in Starpower, then Koopa gets hit. I think it's, yeah, we have the hit function for Koopa. Else if they're not in star power, then it proceeds with the existing logic that we had. And I think that might be it. I guess we also, oh, you know, so not quite. We need to do one more thing specifically for Koopa. So for Koopa, he could either be in his non-shell form or in his shell form. So in the case here, this is when the on trigger is when he's in his shell. So it goes to where you're going to push the shell. We need to do the same thing where if you're in star power, you don't actually push the shell. The shell just, Koopa just gets hit like normal. So here, instead of just saying the player gets hit, we need to check if player is in star power, well then Koopa gets hit. Else, if the player's not in star power, well then the player does indeed get hit. Alright, and now we're good. Now let's test this out. I think that's all good. Let's go ahead and test this all out. Let's, play this. I still have the star power sitting in this first block here for the sake of testing. I'm gonna let it come over here. Okay, so let's test this out. So I should be able to just walk directly into these guys. Yep, so they get hit. Perfect. So this is all good. It's probably, yeah, it just ran out. So now that it's ran out, yeah, now I get hit again. Great. So that is it. That is all of our power-ups. Magic Mushroom, Star Power, 1-ups, coins, etc. I really appreciate you watching this tutorial, and I hope you learned a thing or two along the way. Give the video a thumbs up or down to let me know how I did. Subscribe to the channel to know when the next video in this series is released, as well as any of my other tutorials. If you want to support my work even more, you can become a Patreon member to receive exclusive benefits, including early access to the rest of this video series. Link in the description of the video. Thank you for watching. See you in the next one.